JNGL, and this is a different kind of video because you see that it's actually in real life, and yeah, this is about types of symmetry, and it's just kind of a small thing, but so there's just different kinds, and here's a first kind. There's one called line symmetry. It's kind of hard to write when I'm holding something, but line symmetry. Okay, and then yeah, that's not good handwriting at all, but that's just because I'm holding something. And it's like, does it have? It's the symmetry that you basically know, where it's like if something's folded in half, does it work? Does it fold evenly? And then another kind is point symmetry. I'm just going to write point. And that is, can something be turned upside down and still be the same figure? And then the other kind is rotational. Sorry. That's the kind, if you rotate it at a certain degree that's less than 360, will it be the same? So, the point of even having this video not screen recorded is so that I can show you like in real life. And this is a very bad A, but we're going to see what kinds of symmetry it has. Line symmetry. Alright? Fold that in half. Yes, it has line symmetry. How many? Well, only one, because if you try to fold it that way, that doesn't work. No. Now we have an X here, and it has line symmetry, yes. But it actually has two, because if you see I fold it like this, it also works. I mean, it might not line up perfectly because I can't draw it perfectly, but that's it. Now let's see, point. If this A is turned upside down, is it the same? Obviously it's not. That's a different thing. What about this X? Hang on, I gotta unfold this for a second. Okay, here we go. If we turn it upside down, same thing. So this has point symmetry. Do they have rotational? You rotate this A at any time, and no, it's not the same. This X, same thing. If you turn it like that, it's not the same thing. Or like that, or anything like that. And now we have actual shapes. Does this have line symmetry? And for all of the shapes here, we're going to assume that they're all regular shapes, meaning they have equal sides and angles. Line symmetry. Okay, let's fold this in half. Okay, let me try this. Yes, it has that. It's folded in half, but as you can see, it only has one, because if I fold it the other way, then it wouldn't work. Does it have point symmetry? Turn it upside down? No, it doesn't, because it's not the same. Rotational, though. Since it's a regular triangle, if I turned it these ways, it could be. Alright, now this parallelogram. It does not have any line symmetry, because if I folded that, you could see that it would not match up. Now, does it have point? It does. It's the same thing if I turn it upside down. Rotational. Yes. And a rule that I forgot to mention is, if anything has point symmetry, then it also has rotational. That's the rule. If something has rotational, it might not have point, though. But if you can turn it upside down and it's the same thing, then that's 180 degrees, and it is rotating it. Okay. Square. Alright, well, we fold that in half. We can see that if we folded it that way or that way, it would still match up. And actually, you watch this. It actually has 4, because if this is a square, then it should match up completely. And that's because if you do that, it still matches up. And if you turn it upside down, yes, and it also has rotational. This hexagon. That's not a hexagon. That's actually an octagon. Sorry. I thought I made a hexagon, but actually made an octagon. Sorry. Yes, if you fold that, that works. You can turn it. It has point symmetry too. And then this right triangle, that's supposed to be right triangle, at least. Yes. Or sorry, no. It does not, it cannot be folded. And it cannot, be turned or anything like that. Now, here's how you can calculate the degree of rotation of how the symmetry works. Okay, let's take this octagon, for example. It has 8 sides, and there's 360 degrees in a full thing. You divide that by 8. Is that 45? Yes, I think it is. If it's not, sorry, but that's how you would do it. That shows you that if you rotate it 45 degrees, then it will always be the same thing. And, yes, that's how you do that. That is all for this video. It was a short and kind of different, odd video, but that's what it was for this. Thanks for watching.